Bismillahirrahmanirrahim. Assalamualaikum and very good day to you all. In this video, I'm going to cover the topic 3.15 stress in rotating rings from Shigley Mechanical Engineering Design textbook. Okay, this is the topic I'm going to talk about. Introduction to rotating ring and stress. Okay, what is rotating ring? Okay, uh, things like flywheel, blowers, and everything that is moving, moving around in circles, moving in rotating. This is called rotating rings. Okay. Rotating element like flywheels and blowers experience distinct stress pattern with primarily with tangential and radial stress. Okay. Because it's always rotating like flywheels and blower, kan? And cars, uh, they have the stress pattern. This element can be simplified to a rotating rolling model using stress analysis similar to thick wall cylinder. So when we want to calculate the equation for it, it's better we have the ring model so that we can simplify the calculation. Okay, in engines, rotating crankshaft undergoes release stress which maintain efficiency at higher speed. So condition for tangential and radial stress, uh, radius versus thickness ratio, the outside radius RO of the ring is much larger than its thickness, ensuring predictability in stress distribution. Okay. Uh, so constant outside radius is larger than the thickness. Okay. Uh, the ring of this has a uniform thickness, critical for uniform stress distribution during operation. Okay. Stress remain consistent across the thickness, allowing for reliable performance in heavy machinery. You can imagine the flywheel. Okay. It has the ring, it has the thickness of the flywheel, they have the thickness. Okay. The thickness must be uniform. And the outer radius, the the flywheel has the outer radius. Okay. That's the inner radius. Outer radius is larger. Okay, it's larger. So that the the stress can be distributed evenly lah. Okay. So imagine the things that moving like that, rotating like that. It has the larger thickness. It has the inner thickness, inner diameter, outer diameter. Okay. The outer diameter must be larger. Okay. So tangential stress equation, you can see the equation better in the textbook. Later you have the textbook with you. These are the key variables and the application in the high speed machinery. Higher angular stress raises tangential stress important in design for turbines and high speed engine. Stress equation, uh, okay, and this concentration. So setting this is the radius stress formula you can find in the textbook. And then and special case for this setting RI equal to zero simplified calculation, especially relevant for activities like those in jet engine. Okay. Uh, R1 is inner radius. Okay. Calculation approach is crucial in high speed application like jet blade engine. Okay. So this doesn't have inner radius. Then the this don't have the what you say the hollow cylinder lah, the hollow one. So that is why we call it RI zero equal to zero because no inner radius. Okay, so that's all for the video right now. Inshallah, we meet in the next video. Thank you very much.